In day 21, the third week of entire days of training. So, box has already started. This one is on DevSecOps again. The Yule be poisoned, a pipeline of insecure code. So one of the main reasons for acquiring Antarcticrafts was their crazy automation in gift-giving, wrapping, and crafting. After securing their automation, they discovered other parts of their CI/CD pipeline environment that were used to build and extend their pipeline. An attacker can abuse these build systems to indirectly poison the previously secured pipeline. Understand how the larger CI/CD pipeline operates. Explore indirect poison pipeline execution, how it can be used to exploit Git. Apply CI/CD exploitation knowledge to the larger CI/CD environment. So, connecting to machine today, we need VM, which has started, or an attack box. I'm using my Kali VM, so nothing to do there. I'm on the VPN, so good. Right, so we deploy the target machine, and we're on the VPN, so we don't. It recommends using the attack box, but we'll see how far we get. Right, so CI/CD environment. Often developers or other end users only see a limited portion of the CI/CD pipeline. Developers interact with Git on a daily basis, so it makes sense that CI/CD is the most commonly associated with Git, although it only makes up a quarter of the initial CI/CD pipeline. The diagram below visualizes these general segments of the pipeline: development, build, testing, and deployment. While these segments could be expanded and interchanged, all pipelines will follow a similar order. In the previous task, we looked at CI/CD environments that were self-contained in Git. In a more formal environment, segments of the pipeline may be separated out into different platforms. Below is the CI/CD environment that we'll be exploring in this room, and you'll notice the addition of Jenkins, a build platform, and an automation server. In the next section, we'll explore Jenkins and discuss how these components interact and contribute to the pipeline. Right, so automation platforms. Jenkins, along with many other applications, handle a pipeline's build segment. These platforms can be remote or local. For example, Travis CI is a remote build platform, whereas Jenkins is a local automation server. These platforms rely on runners or agents to build a project on a pre-configured VM. One advantage of some automation platforms is they can automatically create and configure build environments on demand. This allows building and testing in different environments without manual configuration or administration. An indirect poison pipeline execution. So we did a poison pipeline execution yesterday, but let's briefly shift our focus back to the development stage. In the previous task, a poison pipeline execution was introduced, wherein an attacker had direct write access to a repository pipeline. If the attacker doesn't have direct write access to the main protected or branch protected repository, for example, it's possible that they have write access to other repositories that could indirectly modify the behavior of the pipeline execution. If an environment is employing a development pipeline, a configuration file must be defined for the steps the build system must take. If the repository contains all the necessary source and build files, and another repository contains the pipeline file, then write permissions could differ between the two repositories, resulting in an indirect PPE vulnerability. In the example, you can assume that the repository containing the source is not write protected, and the repository containing the pipeline is write protected. To exploit the vulnerability, an attacker would need to identify a file or other parameter that they can arbitrarily change that the pipeline file will then use. Makefiles and other build files are usually exploitable because they're used to build the source and can run any arbitrary command, as defined in the makefile. Below is an example of what this might look like within a pipeline file. To weaponize the vulnerability or PPE in general, the CI/CD environment as a whole must be taken into consideration. For example, if a build server is used to build artifacts on a pre-configuration virtual machine, the attacker can run an arbitrary command within that environment. So, practical challenge. Let's apply what we've learned in this task to the Antarcticrafts CI/CD pipeline. Navigate to the website. Hey Nick. So this is a Gitia platform Antarcticraft uses for their version control and development. Log in using the credentials guest password123 And when you've logged in successfully, you should see two repositories, gift wrapper and gift wrapper pipeline. Then navigate to another link. Let's put this over here. So that's the Jenkins login. Log in with admin. Once you've logged in successfully, you should see a project gift wrapper build. So let's make sure we can get into this. So sign in. Sign in. So there we go. So we've got two repos, and then this was admin. Cool. So there we go. So we've got those two there. This one was gift wrapper build, so we want that. Right. Before looking at the environment's other components, let's dig deeper into the Git repositories. Looking at the gift wrapper pipeline repository, you may notice that the Jenkins file, if a repository is unprotected, an attacker can modify a pipeline file to execute commands on the build system. For example, an attacker could control the build stage by modifying make pipe true to who am I. This is possible because the Jenkins file allows you to run shell commands, as you can see on line 13. So this sh make true. This is an example of PP as covered by the previous task. So to modify the Jenkins file, we use the power of Git. To begin working with the repository, a local copy must be created or cloned from the remote repository. In this example, Gitia run the command below to clone the gift wrapper pipeline repository locally. So let's copy the repo command. Yeah, PP. A big PP. PPE. Alright, so let's put it in downloads. Let's just open a terminal here. We'll clone the repository here, so we've got it there. So the Jenkins file. Once we've cloned the repository, we can make any changes that we want and then commit the changes. To start, we can exploit PP by changing line 13 of the Jenkins file from sh make true to sh who am I. When a commit is created, a snapshot of the current state of the project is saved to the local repository. To add our changes to the remote repository, we must push the commit, and after modifying the Jenkins file, run the command below to add, commit, and push the changes. So let's go back into here. So we need to actually edit this file. Let's do it with the mousepad. So we're just going to go who am I and save it. And then in the console, if I go into this, because I've got ZSH on here, you'll see it just does a nice formatting on it. So if we do cd gift wrap pipeline, I can tell I'm in the main branch already because the ZSH shows me that. So we want to git add and then dot, which means everything here. Then we do git commit m and then put a message. So this would be added who am I as a command like that. I have no author, so I need to set this up. So I doubt you have to do this on the attack box, but if you do git config, see what I'm typing. Global. You know what you should set that message to. So user.email test@test.test, and we'll change user.name to test. So right now, if I redo my commit, it will add it. So we've changed one file. We've inserted the change, and we deleted 2 rows apparently. But yeah, so that tells Git that we've made a change, and then we do git push, and it should push it back to the repository. Username. What should we log in with? Just test, I guess. No. What login do we want for that? A guest, okay, right. Let's try it again. Git push, username, guest, no password, or failed. Did I miss creds? Is it supposed to give us something? Guest password 123, I guess we can do that. We've got the creds, so guest password 123. That's better. Right, remote rejected. So it rejected the git push. So when attempting to push changes to the repository, you'll notice that it's main protected. So you can also try creating a new branch, but you'll notice that the repository is branch protected. This means that we must find another way to indirectly modify the pipeline. Looking at how the Jenkins file works, you may notice that it uses make. If you recall from the previous section, a make file can be used to define a set of rules to execute steps such as commands. The make file is defined in the Git wrapper repository, meaning it could have different protections than the pipeline repository, and an attacker could add malicious commands to it. After also cloning and attempting to push changes to the Git wrapper repository, we'll see that our commit is successful. Depending on the configuration of the build system, different actions may initiate a new build. In this example, we have access to Jenkins, so a build can be manually scheduled by pressing the green play button. So let's get the Jenkins file up again. So if we look at it, make sense of what that text just said. So we notice it uses make. So that's not it. Where have I got? There's my mouse pad. Right, yeah, so here it's just saying you could put other stuff in there, so that's not as interesting. So does it just want me to go into here and have a look? Right. Cloning and attempting to push changes to the Git wrapper. Oh, right. So this is a new repository. Cool. So yeah, we pulled from pipeline. So yeah, so this is the one that's protected. But if we get the other one, the other repository, then that one we can make changes to. So ignore that. You're not looking for make there. You're looking for make in the other repo. So GIF wrapper make file. So we do the 2pip sh 2pip makes the directory for test. RM's the dist. Doesn't do any of that. But yeah, so we can basically take advantage of that and then run cat or whatever we want. Right, so we can check the status of the output. From the build from Jenkins by navigating to the repository. Within the project Git wrapper build, go under Git wrapper pipeline repo and under the main branch name. So was it under build? Git wrapper build under Git wrapper pipeline. So go back to the dashboard. Git wrapper build, Git wrapper pipeline, main branch. So if successfully executed, the command that we poison should appear in the make log stage. So we look at where it is. That's scheduling builds. Click here to look at the build history. We should get an output. Please show me stuff. Console output. So that's what the build stage is doing with one of the previous commits. So there's a who am I. So if we go Honey Bell, Git wrapper, and we want to where's the Git clone for this? Oh, there. Completely blind. Right, so cd dot git clone. We can cd into Git wrapper. And then so Git wrapper, now we can modify these, so we can go into the make file. We know that builds that, so we can go into pip. Just put like who am I? Let's do like echo. Poisoned command, just so I know that that's the who am I that I've added. So we made the change, we rerun git add, and we'll add a new commit, and git push, guest, password 123. And it pushed. Right, so there should be a change. If I go refresh, we added the commit. And then we should be able to go here and go to pipeline. There's one just start. Oh, these are the ones I started by clicking the plus button. So we've got no build yet. If we schedule a build, has it done it? I should scan the pipeline now. We'll queue this one. Right, here we go. So this is the build that we've just triggered. Look at the console output so you can see what it's doing. there's my poison command, and we know it's running as Jenkins, so there's the who am I. So yeah, we can see it in the make stage log. So console output, who am I Jenkins, we can see that, and then so it's asking what Linux kernel version is Jenkins, what is it, what's the node? So the hint we've got is use this command, uname a. So we'll have to make another change. So if we go, let's just do it with this. So we do, what's the file name? So nano2 hit.sh. So this time we'll chuck in echo first question, because this is the first question. We'll run uname a and we'll save this, and then we'll git commit. So we'll add a new commit, first question. Oh shit, we didn't add. So git add, and we're adding to pip. Then we push guest password 123. So we'll see an update to the repo, and then we go into the pipeline again and start another build. So now we've got the 6 build going. Console output. So the first question, and then we've got Linux TryHackMe, so we now know what is running. So let's grab that. So it wants just wants the kernel version, so we want that. You've unlocked a streak freeze. Cool, right, so the value is found from the secret key, so we need to cat that out. And the hint is use cat, yeah, so cool. So I'll go back to nano. Echo second question. Paste in cat secret key, and then we'll git add to pip. We'll add another commit message, so this is for the second question, and then we'll git push guest password 123. We'll see the new second question commit go in and start one more build. Go into build history, we'll get the 7th one. Console output. And now the second question, so that's the secret key. And then we get that, so nice. So the last one is to visit their Discord, which I'm already in. So if you're not already, join their Discord for some reason. That has some relevance to the task, apparently. But other than that, we can terminate the box, and then we are done for day 21. So yeah, hopefully that was good. Again, another good one. If you're not a developer and you never used Git before, I'd probably recommend doing one of their Git rooms. I think they've got one. Might not be. Let's have a look. They got something on Git. Let's do Git and Crumpets. I don't know if they've got any entry-level ones for learning Git. No, that's a flag capture, so that's another one. Committed then. No, maybe not. Alright, well in that case, do not GitHub. So, documentation for Git, reference manual, Git. So that's a better help, I think, for anyone who's not done Git before. Yeah, just learn the basic options for doing the additions of, like, adding new files from the command line, and then like you've got Git branching. So if you needed to create new branches, you obviously need to do that. But yeah, then you might actually, if you're not aware of what the branching strategies are, that might be worth looking at. So Git flow. So this is a very common branching strategy. So it gives a good insight as to, like, the main or the master branch. You branch off of that into a development branch, and then all the commits go into that. If there is a specific feature or something that you're adding, then those go into its own feature branches, and then eventually those get merged back into the main developer branch. And then when you've done enough features, you push in a release of those features into a release branch, and then eventually that gets back into the main branch. So you can see kind of how, like, what the point of branching is from these diagrams. It's a lot more useful than probably reading the documents if you actually see from these examples. So yeah, that's good. And then we can close my shell down. But yeah, that's it. So any other questions, let me know. If there's comments or whatever you want me to respond to, put them in onto the YouTube comments when this goes on to that. And I will see you tomorrow for day 22.